All right, we're rolling. Good. Okay, I want to show you just a couple last-minute sneaky logarithmic exponential tricks. And really, this is kind of the whole point of Chapter 8. So I'm going to feel really good about getting through this last little bit. Sorry, I faked you out a little bit. Sorry, Courtney.
Thanks a lot.
Yeah. Real quick, so couple problems, and these are the kinds that you could see, and you already know how to do these. It's not a big deal. What if we want to solve something like 4 to the 3x equals 8 to the x plus 1? There's a really tricky way to do this. If I can ever get the bases on both sides to be the same, now doesn't it make sense? If I could do something like this, if I could say 2 to the something equals 2 to the something else, what would have to be equal in that equation? If the bases are the same, yeah, wouldn't those exponents have to be, we could set those exponents equal to each other, right? So that's my goal. If I can just write these in terms of the same base, then these become very simple non-exponential equations. Okay, so let's do that real quick. Now, what is the common base, or if I wanted to, what's the smallest base of both 4 and 8? They're both powers of, put that away. I'm going to make this super quick, but you got to just focus. Super math powers here. Just 10 minutes, then we're out of here. What's the base of both of those? 2. I could write 4 as 2 squared, right? So that becomes, this becomes 2 squared to the 3x, and 8 is 2 cubed. 2 cubed to the x plus 1, right? Now, what do we do if we take a power to a power? Multiply. Good. So then these become, this side, this just becomes 2 to the 2 times 3x. So 2 to the 6x, right? And on this side, we get 2 to the 3. Now, I got to put parentheses this time because I'm multiplying 3 times that whole thing, right? So then, right, exactly. So if I go ahead and just distribute, then I know, don't I, that because the bases are the same, that and that have to be equal. So I just have the simple equation, 6x equals 3 times x plus 1. Let's see, I could just divide both sides by 3. I could distribute if I want to, either way. If I divide both sides by 3, I just get 2x equals x plus 1. So what's x? 1. If I subtract x from both sides, right? Okay, make sense? So the trick is just, rewrite them so the bases are equal, okay? And then it becomes just a very simple, then we can just set the exponents equal and solve a simple equation instead. So there's one trick, sneaky trick. It's not hard. Okay, here's another one. And you already know this one too. Now, this is a calculator issue, but once you're using your calculator, and you can, they'll give you a you might be able to use it. I can't remember on this one if you can use a calculator. If you can't, they'll give you one on the test that you can use. I can't remember which way it is. But what if we have something like 2 to the x equals, whoops. Okay, so what if we have something like this? 2 to the x equals 7. How can I solve that? Now my goal, the problem is the x is up in the exponent. Is there a way that we can get that x out of the exponent? And think of those slick properties of logs that move everything down and make exponentiation multiplication. And remember they made multiplication into addition. They always made things easier in terms of arithmetic. So what if I just take the log of both sides, any base I want, so let's just take a natural log. If I take a natural log of both sides, that's just something a calculator is going to give me. But what does my property of log say I can do with this exponent then? Do you remember? This is the one we use a lot. Yeah, I can move it out front. I can put it out front, have it multiplied, so now it's no longer in the exponent, that variable. I can rewrite this as x times natural log of 2 equals natural log of 7. Natural log of 2 and natural log of 7 are just things I put in my calculator. So what's x equal to? How do I isolate x? Yeah, just divide by that weird number, both sides by that weird number. So those cancel, and I just get x equals the natural log of 7, whatever that is, I don't know, over the natural log of 2. And that's just something that my calculator gives me, right? I just go in here and just say natural log 7 divided by natural log 2, and that's it. That's my answer. Okay, but the trick is, take a natural log of both sides so I can put that exponent, that x, take it from the exponent and put it out front so I can solve for it. Okay? All right. So that's another trick. Same thing is true. I just want to show you. See one like this? Same deal. Don't panic. All I got to do is just get this thing simplified as much as I can and take a log of both sides. If I subtract 4 from both sides, I just get 10 to the 2x minus 3 equals 17. That looks pretty ugly because the x I'm trying to solve for is stuck in the exponent, so we just take a log of both sides. Natural log of 10 to the 2x minus 3 equals natural log of 17, just a number. What do I do with that 2x minus 3? Move it out front. Good. So all this stuff just goes out there. So 2x minus 3 times natural log 10 equals natural log 17. And now this is just, you guys are awesome at this stuff. This is just old hat. We're just going to solve for x by working backwards through order of operations. So first thing, we got to work outside of parentheses. What are we going to do first? Well, not minus. It's being multiplied. So I divide both sides by natural log 10. Okay, just numbers. I know they look strange, but they're just numbers. And so then I get 2x minus 3 equals natural log 17 over natural log 10, which my calculator will tell me when I ask. Add 3. And then just divide the whole thing by 2, right? And we got it. That's my answer. Just put it in the calculator. Okay? And gosh, I think. Oh, one more. I'll show you. I'll show you this. Let me show you exponential. Where is it at? Okay. Yeah, this guy. And this is one you already know too. This is just based on properties you've already studied. What if we had base 5 log of 3x plus 1 equals 2? Okay. We can do this one right now. What do we do whenever we see those log statements? What do we, in those first chapter 8 assignments, what do we always do to rewrite those? Well, no, we rewrote them in exponential form, right? We could take this whole thing, and if the left side of the board is going to be kind of log form, we could rewrite that same thing on the right side in exponential form. Remember how we said that? We always said whatever the base is, so 5 to the 2 equals 3x plus 1. What's 5 to the 2? 25. I just solved that little equation, right? No big deal. Now the trick you can also do with this, there is an algebra way to do this. If I want to undo a base 5 log, the inverse of that is a base 5 exponential. So I could just take both sides. I could take base 5 to the power of both sides. But you see, it just accomplishes the same thing, so you don't even really need to do that, right? If I just raise both of those base 5 to those powers, then 5 to the log 5 just cancels, and so I get 3x plus 1 equals 5 squared, but wasn't that easier over there? We already know how to do that. Okay, just rewrite it as exponential, and then solve for x. Okay? I'm going to put an assignment up, but it's going to be a bonus assignment. It's one you can use to replace another one if you want to. I'd recommend you look at it, but I'm not going to make you do it. Okay? So, we're done for the year. All right, let's go. 619.
Why all the way up there?